I'd like to thank all of you for joining us today. We have Mark Gies here from S-5, and his presentation is going to be on rail-less solar metal roofs, solar on metal roofs, talking about best practices for wire management. This is a NABCEP approved course, so we will be providing those in attendance to Mark afterwards, along with your email address, and Mark will then be able to submit your information for NABCEP credits. So with that, let me welcome in Mark from S-5. How you doing, Mark?
Good, great. Thank you, Jay. Thanks very much. So thank you, Jay, for introducing our topic, and thanks to Alt-E for letting us present today. I presented as well last year, and then prior years, S-5 has been part of this for quite a few years. Oh, let me get back on track here. Okay, here we go. So let me, I'll just leave this up for a couple seconds. This is really our copyright information. You can read it as you can. So as Jay said, my name is Mark Gies. I'm Director of Solar Business at S-5. I've been at S-5 for a year and a half now. Very happy here. But I've been in the solar industry for a dozen years now, and a lot of that has been with mounting systems, and a lot of it as well on the technical side. One tidbit of information, actually, we're based in Colorado Springs. I'm actually in the Boston area, just a few towns over from Alt-E. And when I was interested in getting into renewable energies in 2008, I actually attended some webinars, some seminars at Alt-E University in Hudson, Mass, where they were, and I went to a few of those. And that really helped me get into solar. So thanks for getting me into this industry 12 years ago. With me as well is Dustin Haddock, who's our VP of R&D, and David Staller, who's our Director of Distribution. They'll be in the background answering questions as we go along. So there's no real reason for this picture, but I just really like showing this. This is a great picture of a nice looking metal roof and solar on it. As well, another part of our business is snow retention. You can see that bar along the bottom. So that prevents the snow from sliding off, which it will do on metal roofs with solar on it. So to protect the people who may be sitting on that couch in the wintertime, it's very important to couple, in a lot of cases, to couple solar with snow retention. And this is just a great picture to show that. So getting into the objectives, we're really going to start out by talking about metal roofs and how they are really the best platform to put solar on. Then we'll talk about the advantages of a railless direct attach mounting PV mounting system. Sorry. As well, then we'll get into the best practices for wire management with railless systems, and then best practices and for other aspects of installation and balance of system parts like microinverters and optimizers. The focus will be on the design itself, so how the modules and wiring and clamps and metal roof go together. We'll talk about the nuances of wire management, and that'll be focusing on commercial large systems where string ends need to be jumped out from underneath an array and how to do that to get to the home run. We'll also focus on some specific installation techniques, and those will be around steep slope actually, and the nuances of steep slope and maneuvering around the roof. And then we'll get into best practices for module level power electronics like optimizers and microinverters. So the solar industry is no different than any other industry where there's always evolving technologies, new technologies coming out. And that can be daunting to an installer or a developer. It's easy sometimes to look at something, new technology, something new that's out there and say, yeah, this looks great. It's going to save me money. But, there's always sort of a hesitancy. And with solar, that's around the fact that you have, there are installation teams on roofs, and they're well-oiled machines. They've rehearsed, they have very repetitive and reproducible steps that they just go through to be really efficient. So the thought of tweaking that, learning new methods can be daunting. And so this webinar focuses on a few of those to sort of get people over that hurdle, so they're less hesitant to try, using a railless system, direct attach. I'm not going to go into all the pieces of the course layout, but this is the course layout. There are some sections that I'm going to go through very quickly. We have other webinars. If you go to s-5.com, we have a webinar section. We have some of these topics are talked about in depth in other webinars, and the ones we've done, you can always look at, listen to recorded versions of those. One is, for instance, we have one on more in depth in the technical part of why a metal roof is the best platform for solar. So I'll touch on that, but there's other webinars that you can access on our website to get into more detail. So we'll do very briefly talk about the history of metal roofing, and the big part of that is that it's been around forever, thousands of years, metal roofs. Here's some examples. This one's from 600s AD, Dome of the Rock in Jerusalem, St. Marco's Cathedral in Venice from the 1100s, in Istanbul, St. Blue Mosque from the 13 or 1400s, and of course, the Notre Dame Cathedral from the 1600s, and we're approaching the second year anniversary of when it unfortunately burned. It's coming up soon. So why is a metal roof the best place to put solar? And we just talked about one. One is that durability. The service life of a roof, of either a standing seam roof or other exposed fasten roofs, any metal roof is long, much longer than other roofs. It's 60 to 70 plus years. So that window of opportunity that it creates to put a solar system on it that may have a service life of 30, 35 plus years, the window is big. So I could literally put solar on a 20, 25-year-old roof, metal roof, and the roof will still outlast the solar system. That's key. Other roof types cannot do that. Single ply membrane or shingle roofs. If you're looking at a 5 or 6 or 7-year-old roof and you want to put solar on it, people start asking you, do you want to replace the roof first? You really should. But with metal roofs, you just do not have to do that. That's a huge plus as far as your ROI and your total cost of the lifetime of a solar system. As well, sort of aligned with the reason we're all in this business, why we do solar is to help the earth. And steel is the most recyclable material. Steel and metal roofs are highly recyclable. So the combination of metal roofs lasting forever and being highly recyclable, the bottom line is you don't see very many of these in landfills, and you can't say that for other roof types. And last but not least, it costs less to install solar on metal roofs. And we're going to talk about railless, but whether you're talking rail or railless systems, metal roofs are just more conducive to install solar on. It's easier to seal holes if you're screwing into the roof. You don't have to flash a lot. You don't need ballast. Generally, I see most systems out there are flush. So you just have a lot less material. So overall, the cost of putting solar on roofs is less. And we have another webinar, as I said, that gets more into depth into this. All right, so let's talk about what a railless system is, direct attach. So here's a picture of a rail system. And the rails are hidden underneath that module. The red dashed lines are the rails. So this is a steep sloped roof, could be commercial, likely to be residential. And one thing that you'll see in a few of these other pictures is I've always tended to, and this is just my personality, like I like to see the picture of the rails in place, and then I like to see the picture when it's finished. And actually this highlights a really important part that we'll get into about cost savings, is that putting the rails up is actually a project on its own. So before you can even get up there with modules, you're snapping lines, measuring, laying these rails, attaching them to the roof. And then you see these pictures, there's a picture of the before and after. So there's a lot of effort dedicated to getting those rails up on the roof. Here's a large commercial system, multi-megawatt on a flat roof commercial. Same thing. Just imagine the work it takes to get those to that site, get those rails up on the roof, then snapped, connected, and put in place. It's a project on its own, and that you just do not have to do as much with direct attach systems. So I've highlighted the part in the right corner with that red circle. So that really shows the essence of the connection, the interface. So the rails are perpendicular to that long side. And then if you see the clamp, the overhead clamps are pretty tiny, but those are on that rail. And those are really, you use the adjustability of the rails to sort of adjust that clamp so it's tight against the module. So just kind of remember that look. And now we'll get into railless to direct attach. And this is our PV kit, by the way, our PV kit 2.0. But now the part I circled, that looks just like that other picture. So those are rails coming out from underneath, and they're used in the same way. The clamps attach those rails. They slide up and down the rails to cinch up, to tighten up the modules, but they're already part of that roof. There's zero cost to that. Those are the seams on the roof, but they're acting as rails in this installation. So you don't have to buy rails. Here's a commercial system, flat roof system. So in this case, this one is a high wind situation. So high wind pressures were calculated for this, whether it's in a specific area that's windy, or it's a high building with a large height, it's a high building or something else. But we needed to have 6 attachments per module. So in this system, you would buy 50% more clamps. But if I actually had a rail system, I would be buying 50% more rails to accommodate this. So this is a typical commercial flat roof system using a direct attach. Here's another one. Same situation. This is in a high wind pressure site location where 3 clamps per side is needed, 6 per module. The internal ones are shared, of course, but again, the rails are already there from the seams from the roof, so you don't have to put those extra rails in to get your 3rd attachment point on each side. So we like showing this. This is one of the mothers of all PV systems out there. This is 7.5 megawatts on Apple's headquarters. It's on standing seam roof. It uses our direct attach system. Besides the modules, there's 6 miles of walkways, 2 miles of edge copings, and 6 miles of fall protection that are up there. So all in all, 100,000 points of attachment, no holes, no ballast, and no warranty violation. Beautiful. So here is our direct attach system. There are other ones out there, but this one is ours. So you can see that overhead clamp. We call that a mid grab, and that's fastened to a rigid standoff. And below it is where it's attached to is a stainless steel disc. That's the base, and that is actually a listed bonding and grounding device through UL 2703. So those 2 modules are bonded together and could be used as the ground path. So there's no lugs, no jumpers between them. They are bonded together through that product, through that listed device, which is our PV kit. Here's a side view showing the mid grab and the edge grab for interior or perimeter. From the disc up is the PV kit, is our direct attach system. Those barbs you see on the base, those are what scratches the anodized layer of the module frame to provide that bonding. From the disc below is any of our clamps or brackets. So that creates a modular system that really dovetails well with our expertise in metal roof attachments, because the PV kit can be used with all of our clamps for standing seam roofs and many of our brackets for exposed fasten roofs. Here's some of the benefits, and we'll get into more of these. These are partially assembled, so it saves time when you're there to assemble these. They attach to a pretty wide range of module frames. One tool is needed to attach this to the roof and then to attach the module to it to tighten the overhead clamp. The big thing is that this is 80% less weight than a rail. And we'll get into that more, 25% better load distribution. There's more touching points to the roof generally, so that provides better load distribution, which is nicer to that roof. And the big thing is that, and we'll talk about this, is that these clamps are located on the fly. So you do not have to put any of these ahead of time like you would do or have to do rails. It's there, and that's the big time savings. They're installed on the fly with the module. We'll get into that. Made out of aluminum and stainless. As I said, these are UL 2703 listed. There are slots for wire ties to tie up, jumper cables and jumper power conductors and the power conductors. Our design is a low profile, so it reduces wind forces, less material, more cost savings to you. And as we can see, talking about the metal roofing industry, there are a lot of standing seam roof types, many, many, many out there, tons of them. And our philosophy at S-5 is to design a clamp that's specific to each one. We have a few universal ones, but we tend to want to design specifically. And the reason for that is it's more efficient from a material perspective, so it's a lower cost. It provides better performance from pullout, and it's easier to install. And any of these work with the PV kit. Here's a good side picture I like to show. This shows how low profile this is. You can see the edge grab on the perimeter, and then where those red circles are, those are the mid grabs. But it's the PV kit. One thing we'll talk about is air flow through this. And since if this was a rail system, it would be higher, there'd be rail across, but having this with standing seam roofs, you create sort of a chimney effect in these little compartments between seams that really help draw that air up and help keep the temperature down for use. So that is a concern. So the concern is that it is a low profile design by design. We did that on purpose to make it make it more robust. So there's a question about airflow and about module temperature. And if you talk to a module manufacturer, they want it as much as possible, but the fact is, whether you have 4 inches is a sweet spot, and up from there, you get a marginal effect from that gap getting bigger. So there's not much of a difference between 4 inches and 10 feet on that temperature underneath the module. And and there are documentation out there, research from tests done that show that if you're in that 3 to 4 inch range, it starts getting optimal. And as I said, our focus on the design was to make it flat, make it low profile to reduce the effects of wind on a system, because the higher you are off the roof, the higher the wind forces. So we're always, I think 3.75 is our minimum, but we're, in between that and 5 inches is generally where our products, the clearance you get with our products. Here is that stack up. I'll go through this pretty quickly. You have a seam, you have our product, and then when the module goes on it, you end up with, about, less than 4 inches, 3.75, and that varies depending on that seam, your seam height to 5 1/4. So enough to keep that module cool enough. So I'm going to talk more about the stack up and at the same time introduce other brackets that we use with our PV kit for other types of roofs. This is our rib bracket. We have a handful of those to fit different trapezoidal roof profiles. It is installed above the floodplain, which is the base of that panel where water will flow. It's above that. It's attaching directly to the metal sheet. It doesn't go into structure. The rib bracket has a double seam. There's this EPDM seam on the rib bracket, and then there's a EPDM gasket on that screw. That screw is a special screw that we designed. It is a self-piercing screw. It's a carbon steel screw with a stainless steel cap that protects it from rusting. There's that gasket. But since it pierces the metal, it creates a little tunnel that adds a little bit more thread. And that increases your pullout by a little bit. As well, if you had a self-drilling screw, you would end up with what's called a swarf. Oops. A swarf, which is kind of a cool word for a chip. And that chip or swarf would fall on the metal roof and cause damage from rust. This thing has a wire management channel in the middle. It has a slot on top for adjustability, and there's a picture on the right showing it with a PV kit. Our Protea bracket is our best-selling bracket, and I call it the universal rib bracket because it fits on any trapezoidal roof profile. Not only that, is that L bracket on top. The L foot on top is adjustable up and down, so it can help aesthetics from adjusting, being able to align your module. It has the same double gasket. It has that EPDM gasket plus the same self-piercing screws that we have for the rib bracket. For corrugated roof, another common roof profile out there is corrugated roofs. Our core bracket works for that, and specifically the 100 TPV is designed for the PV kit. Again, the same concept. It has double EPDM seal. It's screwed into the sheet, not into the structure, and it is above that floodplain. And the stack up is close to 4 inches as well to the back sheet from that. One thing we've heard from some installers is that the low profile actually helps keep animals out. I know one specifically that said, I don't even worry about it with your low profile system. I don't worry about, pigeons or seagulls or squirrels or whatever getting in underneath. And that is, that continues to be an issue with a lot of other systems that are more high profile. So with a lot of rooftops, we do not leave you hanging. We have your back when it comes to figuring out what the best clamp is for the roof that you're installing on. We have an online tool that will help you select if you know the make and model or some dimensions. But as well, we have a great technical support team, and an application engineering team. So if you get a hold of us at support@s-5.com or call us, get to our support line. If you send us pictures of the seams with a ruler next to it, that's all we need. We do this all the time. We help people identify the seam and what clamp is the best clamp. So we have your back on this. This is an easy task that we will help you with. Overall, the benefits of a direct attach system, we'll get into these. The big ones are less material, less labor. Those are huge. Less freight and less logistics of not having to handle rails. With our system as well, you have that reduced dead load because you don't have rails. It's 80% less load. You have higher distribution. As I mentioned, there's just more touching points to the roof than with a rail system. And it's a natural critter guard, as we've heard from some of our installers. That's a bonus. All right, so here, getting into the actual installation, here is a video with Sean Haddock explaining the basics of installing it. If I can get this to work, I hope it's not too jumpy for you guys. It is high speed, and you're lucky that I don't have the volume on because he sounds like a chipmunk. So so you put that first row in and you snap that line. That's the only ones that have to get done ahead of time. Put the module in place, tighten that down, and then here's the key. So the next clamps go on the fly. They didn't have to be there ahead of time. See that he's putting them in as he's laying that module in, tightening it up. That's the key to the labor reduction. We'll see that one more time. Hold on one second. And then you just build up from there. And we'll get into that as well, but we suggest you build a column at a time. So here he is. Here's sliding that PV kit in place as the module is being laid. So there's no pre-laying, no measuring. It goes in on the fly and tightens up. All right, so I'm going to get into a little bit about the economics very quickly. We also have this document online if you want to get that, and we talk about it in other webinars. So we took a real project and really looked at it as accurately as we could to be as transparent as possible. We compared really just the parts associated with racking. So the rails versus our direct attach system, not the modules or inverters. Those are the same. It's 150 modules. Here it is with rails. And the thing about with rails is it's common to see this in portrait mode. If I'm looking at that roof, it's portrait. The modules are portrait because they're perpendicular to the rails. And I mentioned this already. I'll say it again. But the rails are perpendicular to the seams. With a direct attach, our direct attach, the PV kit, The modules are still perpendicular to the rails, but as I said, the rails are the same. So now you end up with a landscape orientation is the best way to approach this. Same number of modules, a lot less labor, 4 days versus 6 days from what we analyzed and calculated. Here's the bill of material, big difference in price. And plus you can just see how much more complicated the rail system is from just components. So the bottom line, and I'm skipping to this, is overall 38% savings in total cost associated with the rails or with the attachment system. 42% less cost of materials, 30% less labor, and 61% less shipping costs because you're not lugging around rails. Other factors, the weight, as I said, I'll go through this quick, 85% less weight in comparison to rails. And since there's more points of attachment, it's easier on the roof, less point loads on the roof at each one, and the roof, the area on the roof is the same. A picture is worth 1,000 words. I say that wrong a lot. Here's 250 kilowatts of rails going to a site and weighs 5,000 pounds. Here's 250 kilowatts of a direct attach system, our direct attach system, PV Kit 2.0. Big difference. Okay, so now let's get into what rails do and what you don't need them for. And we're gonna get into wire management and the installation methods on steep slope, and then module level power electronics. So truly rails, what they really are they are the interface between modules and the roof. They are not there for structural purposes, for some kind of structural capacity. Yeah, once they're on the roof, you put them on, they have to be strong enough, obviously, but they're not there for that. The main purpose is to interface the geometry of the module with the geometry of a metal roof. And we'll get more into that. That's the purpose of rails. But as we said, the metal roof seams will act as that perform that same function. So again, to drive that point home about the orientation difference, if you're looking at this from the bottom, you can look up, it's in portrait orientation because the modules are perpendicular to the rails, and those rails are going along the clamps, where you see the clamps, and they're perpendicular to the seams as you see above to the right. Whereas, and I'll show this later, with a direct attach, those would be oriented 90 degrees differently because there would be no rails there. They would be attached directly to those seams. Here is showing it again. So the dashed line, there's a rail under there. This also highlights the fact that there's 3 attachments from the module to the rail, but only 2 attachments from the rail to the roof, and that's pretty common. So on the direct attach system, every connection to the module goes directly to that roof. So there's more touching points and there's just less material in there. The load transfers directly to the roof from the modules, the forces on the module. Okay, here's another picture. Here's portrait with rails. Oops. And here's landscape with a direct attach system. And you can see the seams. So let's dive deeper into this, how everything fits together. So as you know, this is a typical module that you get in an install manual saying where the loading zones are. They're pretty similar. There are differences though. So this one, the green zone, is rated for the higher snow loads. The yellow is for lower snow loads, and the red is you cannot put your primary clamps there. You may be able to put a 5th and 6th clamp in the middle in that red, but you cannot put your 4 clamps in any of the red. So now let's look at seams and ribs on a metal roof. They vary, they're different. A standing seam roof varies. They can be typically between 12 and 24 inches, can be more. Other types, what we call exposed fasten roof. Those are the ones I showed you, trapezoidal roof or corrugated roof. The trapezoidal roof can be 6 to 12. They're tighter than standing seams, and the corrugated are even tighter. The US standard is 2 3/4 between the corrugation. Trapezoid can be between 6 and 12 inches, and it varies depending on the product. So it's a geometry puzzle to match up those loading zones with the available seams and ribs. This is a real case and a layout. And this one, the seams are 42 inches apart, which is very wide. Typically, the tighter the seams or ribs are together, the easier this is, the less work it is, less complicated it is. And even with corrugated, which are 2 3/4, you can basically grab a corrugated, one peak wherever you want to match up with the loading zone. So in this specific case, there was a requirement to put a 10-inch gap between every two. However, you may look at that and say, wow, that's taking away from my my solar zone, my power density, but it provides great operations and maintenance aisles, and actually, which O&M, and actually for the installation part of it as well, it provides, a great way to much easier do this installation. So this is an example, and I know a few specific installers who really like doing this exactly this way, putting two modules together and then having an aisle between them. So all that wiring, all their microinverters or optimizers can be facing outward towards those aisles. So every module can be directly, dealt with either through the installation, which will be faster, and later down the road for O&M, being able to quickly go to a module that's having problems, take it out, fix it, do whatever you need to do, and without having to crawl over. If these were all tightly packed, it would be a different story. So in essence, if you really look at this lifetime ROI of a system, these access aisles help. But I know we understand there's a lot of pressure to definitely put as many modules as you can on a roof, but there's definitely benefits to having some aisles periodically. That being said, most cases it's pretty minimal. This is the FedEx building, 2.5 megawatts. This is probably a larger space loss than you typically see. This is 7% space loss from these gaps. Typically, it's less than 1%. In many cases, especially with trapezoidal roofs or corrugated roofs or standing seam that are pretty tight, it's really not noticeable. But it'll be good to have aisles periodically, as I said, for O&M anyway. That's always a benefit. So those can be designed in. All right, so now I'm going to get into the nitty-gritty of the wire management. This will be repetitive for you, but a module has a junction box with two power conductors, a positive and negative. The trend now is you see a lot of these with split cells where you have actually, instead of one junction box like this, you may have two side by side, or you may have two that are diagonal that are far apart. So, that's just different. The junction boxes are looking different, more and more different. Then those are kind of put together to form a string. Not talking about micro inverters here, but to create a string, you basically attach modules together in series, and then you end up with, at the end of it, another 1 plus and 1 minus DC connector that has to go to your home run into your inverter. And that's where the nuances happen. So within the strings, and as you lay down, you can see these connectors. Those all have to be tucked in. I mean, you have to have, when you're done with an installation, you can't have wires on the roof. They have to be clipped up or, kind of somehow suspended above the roof. And our product, our PV kit has, this is the old one on the middle and the one on the right has a slot as well. So you can either clip things on the module as shown in that picture, and or clip them to that disc itself. So recently, and I want to stress the importance of this, one big part of doing railless is the module prep. So I showed a picture of clipping a lead to the frame. We just recently had actually a live roundtable with some solar experts, and one point that came across loud and clear is that the more you prep a module before you install it, the easier it is to install it. And that's true across the board. But what we think Railless does is Railless forces you to think of that more. So this is an example of using clips to clip that conductor, the connector, exactly where you need it. So when it gets on the roof, that installer can just grab those and connect them together and finish his installation. That's key with Railless systems, is to produce a reproducibility and a repetitive operational step that creates this efficiency in installation and gets rid of the hassle. So, you need the time to prepare, figure out exactly where you want, how you want the wires to be clipped up, and train on that. So that's repeatable, reproducible. And so you end up with less time installing on the roof. Very important point that came out of our recent roundtable we talked about. And there are clips, and the clip industry has gained momentum, and there's really a large selection of clips that can be very specific to the needs that you need. Multi-lumen or single lumen can have rubber coated wires attached to wire tie. So this makes it even easier to not need rails to zip tie wires on. This can all be done on the frame in a staging area before they get installed. So in a subarray, the next step above strings are a subarray. So the subarray being a collection of strings, you also have a collection of the string ends, which are the pluses and minuses, as I so highlighted there. With a small system, it's pretty simple. What you need to do is you need to jump those pluses and minuses out to the home run to go to the inverter. So, and as the system gets bigger and bigger, like a commercial size system, as you'd see on the right, that could be a typical subarray. There could be a bunch of them around the roof, but you have to get all those string ends to that home run. And that's where the nuances are. So once you get to that home run, and there's an example of a combiner box as well, it's really no different. It's all the same. Once it's out from under that subarray, it's really the same whether you have rail or railless. You have an open home run that it could be covered if you need to, it could be conduit, and that's just goes to your inverter. So that's really where the things are the same. It's before that, from the string ends to that home run, where things have to be planned out and done a little bit differently with a railless system. So another key point, and this also came out of this roundtable we recently had, is strategic string design. That is very important. And if you look at the difference between the one on the left and the one on the right, the one on the left is sequential. The one on the right is really putting a thought into, okay, how can I minimize my string runs, my jumpers, make it easier to get to that home run? And this can be done at your desk before in the pre-planning part. And this is so critical. This could make or break a project, and where your string ends end up. So before we get into the writing, here's another example. And this, I think, is for sort of an idealized design of string design. I mean, it's a big subarray. We split it. So on the left is exactly half a string wide. So you have all your string ends on that right edge. And then in the left one, it's the same way, every string end is at the edge. And that it's incredible how much time that will save you, regardless of what you're doing, even if it's a rail system, to, connecting those to your jumpers. Can be done during the installation, after, and you can use a wire management tray along the edge to run your, all the bundle of jumpers to your home run, or those can be tucked up underneath the module. But this highlights how much of a benefit you can get from strategic string design. And that's more critical with the railless system than with the rail system. But it's as important with the rail-based system. So here's a residential system. With a residential, it's not as big a deal. You only have a few strings you're talking. Those can go direct. It's better to get those out from underneath your little subarray. Your array. And then you can wire, then you can just run it along the edge, and then that can be brought to the inverter. That little piece of conduit is all, everything's in there to go to the inverter. Again, you can use the slots to support some bundles of your conductors. So getting back to the commercial size, one method that you see out there is the direct method. So you're really just taking every string in and you're just running a conductor to the home run as quickly as you can. And as you build, you're clipping it up onto the frame or out of the way. And you can see that the strategic design was better. There's still no right answer with all this. And as I said, this could even be better improved, and I'll show you that in a second. But it's all about where do I put my string ends to make it as easy as possible for me to get to that home run. And the more you clip, the more time is involved in clipping. So here's an example. So the wires are on the ground, on the roof surface. That's fine. They have to be up when you're done, of course, but those are put in ahead of time. That's a direct method to that home run, which is on the eave side, on the top side. I'm sorry, the ridge side on the left. And then the picture on the right is after, and then when they're finishing up, tidying up the wires. This is, by the way, our original PV kit. So those had to be put in ahead of time. Our new PV kit, you would not see those PV kits there. Those are done on the fly, which is, our time savings. So as I said, there's no issue temporarily laying the wiring on the roof surface as long as you pick it up and tidy it up. So again, showing this example of the perfect string design. All those, you have access to all those. You can clip all those jumpers can be bundled together in a wire tray. So this, you can just imagine how much time this saves. So the closer you can get to this type of a thing, the better. I definitely know installers who will design their subarrays around their string size to make this happen. And even if there's an obstacle in there, they'll just make that one string one less so they don't complicate the strings. And they literally live and die by subarrays that are sized by string sizes to make this happen. However, it can't always happen. Our recommendation, if you have large subarrays and you have some string ends in the middle, is to use, one idea is to use a wire management tray inside underneath that subarray. So what that does is it allows you to bring those wires and clip them on the frames only until directly to that wire tray. And once they're in that wire tray, they're just left alone. They're bundled together and they go right to your home run. So there's a lot less work involved with doing that. And on the right is actually a rail-based system, and they're using one. It's worthwhile for them, less zip tying on the rails. So you see that string end, and they're just zip tying it on the rail till they get to the home run. And then once it's in the home run, once it's in that wire management tray, they don't have to worry about it anymore. And those are all laid in ahead of time. And it's in that wire management tray that you get the benefit. You get your benefit from having to clip a lot of wires on modules. This is a variation of it, and this is probably very common, and it's common to my idealized solution I showed, that you have one access aisle in there. You split those string ends, so some are going to either side. You have either a wire tray there, or if there's not that many of them, you just tuck them underneath that edge module. Easy to access for O&M, easy to install, saves time in installation. It's a variation of the method that I'm showing you about designing the strings so they're as close to minimize your wires, and then creating the best path for them to get to your home run. All right, so I'll jump to installation techniques itself. And we're going to focus on steep slope. I mean, that's where people view having rail base as actually using the rails as part of their support structure, standing and leaning on them, which is not needed. And I know one thing Dustin has told me is if you have rails on a system just to install and have footholds for installation, it's pretty expensive scaffolding. So let me tell you a little bit about the column by column method. So The key, as we showed in that video that Sean Haddock did, the clamps are installed on the fly and the module is the jig. That's your time savings. As much prep work as possible done on the ground. You can pre-build your PV kits on the ground before you get them up on the roof. And I'll show you the column by column. And the primary benefit of that is that you just getting access, which I'll show you, and then scaffolding is easier and you don't have to move it very often if you do column by column. So you do first snap a line and put the clamps across that front edge, which we saw Sean do. Then you put your first module in, and then the next clamps go in on the fly. As you're putting that module in, those PV kits go in and get tightened in place, as we saw in the video. And then you keep going. And then as you build and before you tighten, you kind of tap things around to line them up as best you can, so you end up with an orthogonal system. And then you move your scaffolding over. So you're always on the left side of this, and you're always leaning over and building that column and going up with the column. And then you move the scaffolding over and you build the next column. So on and so on. Now, if you were to build that row first, which is common with rail-based systems, you're basically cutting yourself off. So from then on, you'd have to climb over those modules to build more or up and around. And you just wouldn't be able to have easy access to scaffolding that you can keep in place. You're constantly moving things around if you do it row at a time. So column by column is a better method to install our direct attach system. Don't take our word for it. Here's a few testimonials. One is from the owner of Solar Revolution, Doug Claxton. He's been using our PV kit since the very beginning. He did that project that I showed you earlier. He would never go back to a rail-based system. I'm paraphrasing, but that's what he says. And as well, he's really looked closely at some of the knockoffs that we have, that there are for our type of product. And he's always come back to S-5. So as well, this is the first large railless system in New Zealand. And they fell in love with the product. You can see by the testimonial from Luke. They also did time trials, and they ended up installing panels, one panel every 180 to 120 seconds. So a column of 17 and 21 minutes. And they will never, they'll never use rail again. And they saw these cost savings, 20% cost savings, 85% reduction in weight. So here's showing the actual installation and using that column by column. The ladder there is being used as a scaffolding. Of course, the installers, has a safety harness and fall protection. There's a scaffolding below them too. So you build column by column. Again, the key to this, and we talked about this before, is prepping that module in a repetitive and reproducible way so that it's very easy for the installer on that roof to just plug and play and not have to screw around with, where that wire is. Do I need to tuck wires underneath after I'm done? That work ahead of time, and people need to be trained and be able to be good at this. Really saves a lot of time and creates this, what we talked about earlier, the well-oiled machine. This is it. A combination of that prepping and then a good string design, and saves time on the roof. So, if you look at alone and say, oh, a railless on a steep slope, it's difficult. What I'll say is it's very difficult overall to install on steep slope roofs, rail or not. So we have to keep that in mind. And these are some extreme pictures, and kind of funny, kind of sad, of just how difficult it is to install on steep slope. So when you get a pitch that's maybe 612 getting into 812, you can't really stand on it on your own. You need a scaffolding. And when you're even 10, 12, 12, 12, which is a 45-degree angle, you really need to have scaffolding. And rails may seem to be a good way of maneuvering around and stepping on them, but they really aren't. And they're not always the best, and they're not needed. And as Dustin says, if you're putting the rails there only for scaffolding because you need scaffolding, it's expensive. So again, showing the column by column. So that installer just walks up that scaffolding as more modules are getting put on, and then you slide over and start at the bottom and do it again. That's how it works. Of course, there's still some difficulty. There's still, some stretching may be required. But as I said, any railless, it's tough on a steep slope because you have to be tied in, you're leaning forward, you don't want to fall. So it's tough. This is no tougher, but no, it's no tougher. Showing more of that, it's just important to have scaffolding, safety, of course, fall protection and safety harnesses. As well, specifically with standing seam roofs, there are products out there that attach to the seam in the same way for fall protection, for scaffolding. This one is from Metals Plus. And some of them they actually buy our clamps and build them into their products to be used for fall protection. So, but this is just easier because you don't have to, you can use the seams as well for part of the fall protection in the scaffolding. Another benefit of using a metal roof for solar. All right, so let's get into module level power electronics. I'm going to really subdivide it between optimizers and micro inverters, and I'll tell you why. So on the left is a micro inverter. On the right are optimizers, and when I've given this before, I used to say, yeah, I mean, you can go either way, whether you want to put it on the module frame or on the roof. But talking to more and more people, I don't know anybody, I've never talked to anybody that puts an optimizer on the roof, because it's really simple to do this on the ground, and optimizers are DC. You still end up with two conductors, a positive and negative DC. So if you install that optimizer as shown, or something similar, clip up those wires, you end up with two conductors that make that optimizer seamless. So now you just put that module on the roof and install it the same way you would install it if it wasn't there. And I'm showing the same slide with clips. There's a plethora of clips out there to help do that in the best way possible. So you really don't need rails to make this all happen. So, my thought is it's a no-brainer, and everybody I talk to says put it on the module if you can. But there may be some cases where you can't. That may be an AHJ may force you, the module manufacturer may force you, say you can't put it on the module frame, or maybe it's too thick or some other reason. So we can definitely support putting these on the roof. That is actually, there's an optimizer on the left, and I think that's a microinverter on the right. So you can use a clamp to hold it up, very simple. We also have a utility product, which is our gripper fix, which can span two seams and can also be used to put electronics on it as well. Here's a core bracket in the same way as you would use it to put the PV kit on. It can be used to attach power electronics. Same way with our rib brackets. They're used for the PV kit. They can also be used for this microinverter. But as I said, optimizers, I would just suggest you try to put them on the frame if you can. It makes life a lot easier. Microinverters are not as clear cut. So microinverters, you have that AC trunk, and that interconnects all your microinverters. So you really can't do what you can do with an optimizer. You can't prep a module so that it's seamless. You throw it up there. You have to, if the microinverter is on the frame, which is very common, you have to, when you install it, you have to attach that trunk to the microinverter and then clip that up. So it's not uncommon to see this done ahead of time. The picture on the right, the microinverter is attached to the roof ahead of time. So all the microinverters are attached ahead of time. That AC trunk is all interconnected ahead of time. And then when you lay the module in place, you just clip up that AC cable on, with the appropriate clip onto the frame. Oh my God, I'm running out of time. I've not been keeping track of time. So I'll wrap things up. Besides the inverters, micro power electronics and the modules themselves, there's a lot of BOS products that you can also use the same clamps as you install the modules with that hold those up. Those could be home runs, wire management combiner boxes, other inverters. we have a product. I mean, of course, we are above and beyond. Before anything, we are a metal roof attachment company. So we will make an attachment to hold any of this stuff. As well, walkways, safety, fall protection lines. We have clamps for all that work with all that. And a lot of them, the fall protection products, they use our clamps and build them into their products, which are then certified for fall protection. Don't just use our clamps alone. All right, so I'm going to wrap up by just talking about S-5 just for a few minutes. It was founded in 1992 by Rob Haddock. He's been in the metal roof industry for 49 years now. He's one smart cowboy. He saw the need to safely and simply attach things to standing seam roofs and came up with the clamp, and we built the whole company around it. So as I said, we have tons of products that are for specific roofs, clamps, and brackets for other types of metal roofs. And we are the market leader in this space. We have a lot of things to be proud of. And some of these are the reason I came on board this company. We have 2 gigawatts installed. We do a ton of data testing of our product, and that has your back. We have your back because we have that data that you can easily access through our website or from us and get that technical support to help you with permitting issues, with any issues, showing people that, these products are strong enough to stay on your roof using our clamps on metal roofs for solar. If you look at the solar landscape, we touch on all these. We're involved in associations. That's another thing I'm very proud of, and why I joined the company is they spend that time. We're helping the industry evolve by being involved in these associations at a leadership level. And we've been doing that, and the company's been doing it forever, and that's a passion of mine as well. We're ISO, so we have a manufacturing plant in Texas. It's ISO 9000 certified. Since we have these listed products, we are regularly audited by UL, FM, ICC, TÜV. So keeps us on our toes, keeps us producing high quality parts. The roofing side of it as well, we are approved. We spend a lot of time establishing relationships with the roofing companies and the roofing associations for the same reasons. We get their endorsements, they approve our products, we listen to them to design products that are safe for the roof. Our manufacturing plant, as I said, ISO 9000 certified, one of the cleanest manufacturing plants I've seen. It's near Wichita Falls, Texas, and it reflects our philosophy for business: a high quality, clean manufacturing plant. And that's all.
Fantastic. Thank you, Mark. Thank you very much. Appreciate your time. Appreciate everyone who's on the session. Appreciate you joining us today. We do have one more session coming up next with Tamarack Solar. If you've registered for that, you can join us there. And then I want to remind you at 3 o'clock Eastern time, so noontime Pacific, we are going to have a open networking session, and you'll be able to talk to Mark and Dustin and David, in that session if you have more questions for S-5. So again, thank you all for joining us. Appreciate it. And Mark, great presentation. Thank you very much.
No, thank you for having us. And did we answer all the questions? I wasn't paying attention at all about questions, David or Dustin.
Yeah, for the most part, Gail's got one there. It's just to further discuss about using a clamp directly over a clip that's fixing the roof. It is important that you recognize the type of clip that the roof is attached with. There's 2-piece clips, which means you can put a clamp directly over it. And if it's a 1-piece clip, then you want to avoid the clip. And yes, Gail, what we're fixing to is the roof, and it's important to make sure that that roof is attached adequately.
Right.
And this is David. Let me just add one more thing. I know we need to bolt here. We will be on the networking, and there's also a phone number for technical support. And Mark's email is up on that screen as well. Dustin and I, our emails are the same. It's just D-Staller and dhaddock@s-5.com. So feel free to reach out to us one-on-one with any questions or call our support line. We're happy to help.
Okay, guys, we're going to have to leave it there. But thank you very much. Great job. Thanks a lot.
Thanks, everybody.
Take care.
Thanks, guys.